Yes.
So if we start discussing about the combinations, so before starting the combination, let's see why we need to combine the resistors. Okay, because when we are using a single circuit or a single path, so that is not a big problem to connect resistor in the circuit or to find out the values. That is not a big deal. But when we are dealing with a complicated or very detailed circuit, so in that process you know that there is only one main supply, and from that main supply all current is going to flow in the components of the circuit which are connected in the whole circuit, right? There are multiple
Yes.
components over there, so we need to fix resistors according to their output of the electric current. So that is very important. So first of all,
Yes.
let's suppose if we have three resistors, one resistor is of 3 ohms, second resistor is of 2 ohms, and the third resistor is of 4 ohms, right? So these are
Ohms
the
is resistance.
ohm is the SI unit of resistance, right?
Oh, okay.
So these are different resistors and these are fixed resistors, right? They are not variable. We are only talking about right now fixed resistors, right? So these are the
Yes.
values of resistors. But now in our circuit, our requirement for the circuit is, let's suppose we need to connect a resistor of 10 ohms, right? We required a resistor of 10 ohms, but we only have three resistors of different values, and all values are less than 10 ohms, right? So that is the problem, that now we have only 3, 4 and 2 ohm resistor, but we need to connect 10 ohm resistor in our circuit, right? So that is the problem. So we know that if we combine those resistance, so 3 plus 2 plus 4 will give you value 10, right?
Yes.
But before connecting them, we need to identify the direction of connection also, right?
Like you are saying that resistance one's resistant two and resistance
Yes.
three is in circuit, yeah?
Yes. So if we have a resistor like this, so there are two possibilities. Either we connect these resistors in one by one in a straight line, right? Or either
Yes.
we can combine them in a single column, right hand on one side, left hand on one side, right?
Mm.
So
So
before,
like you balance it.
yes, yes.
How
So
do you balance?
yes, so that is the main question, and that is the topic today we're going to discuss about. So let's suppose if we take the example of assembly in our school or colleges. So you saw in your school life that every day in the morning or in the break time, that all classes, let's suppose if we are talking about class 7, 8, 9, so there are three classes. We are taking example of three classes, not all. So let's suppose class 7 or the student of class 7 are standing in a straight line, then student of class 8 are standing in another line, then class 9 students are standing in this line, and before that 7, 1, 2, 3, 4, 5, 6, and after 9, 10, first year or A levels, how many classes are there? All are standing in a straight line according to their classes, right?
Yes.
Let's suppose if we start moving from 7 to 9. So we are moving in increasing order, right? From 7 till 8 till 9. So that is
Yes.
kind of a series, right? When we are discussing about a word series in our daily life, so series means one by one, right? The first
Mm.
step, then the second, then the third, then the fourth, and go on till the last value, right? So that is the series we are discuss, or we normally talk about the series word in our daily life, just like we talk about the recently football world cup. So that is all matches are already scheduled one by one, so that we call football series, right?
Yes.
Because there is a step by step process till the final match, right? So when we are starting from one end to the other end, so that is the series combination, right? And let's suppose if we are talking about the two matches at a time, right? So we use word parallel. Let's suppose there are two matches parallel played between four teams at the same time, right? Two teams are playing in the other stadium, two teams are playing in the other stadium at same time, right? So that is
Yeah.
parallel meanings, right? Or we use word parallel for that purpose. So this is the concept between series and parallel in our normal daily life, right? So let's suppose if we are going to discuss about the resistors. So for resistors, there are two terminals of each resistor, right? So
Yes.
if we are connecting them end by end, just like the example of class 7, 8, 9, let's suppose if we take the example of a student over here. So this is the right hand side of the student of class 7, right? And
Yes.
this will be the left hand of class 8 student, right?
Yes.
And again continue the same process. So right left, right left, right left will be the combination of each student with the student of different class, right? So there is a
Ye-
combination of left, right. So when we are joining end to end, or when we are joining components in circuit end to end, so that combination is known as series combination, right?
Yes.
And let's suppose if we take the example of students of a single class, right? Let's suppose if we're talking about class 7, so this is the left hand side and right hand side is already mentioned. So when we are moving in a straight line like this, so right hand of all students are in one line, right? When we are taking one arm distance or when we are marching in a straight line, so our left foot and our left hand, or you can say our totally left hand side, are same for all students, right?
Yes.
And right on the other hand. So that is the example of parallel combination, right? Because all
Yeah.
same ends are at one end and all other ends are on the other side, right? So these are two different combinations. So we need to find the formula that how we come to know that either we are going to combine these resistors into series or we are going to connect them into parallel combination, right? So this is the problem for us, that we don't know that what will be the combination of the resistor. So now let's start with the series combination first. If we talk about the series combination, so in series combination, we already talk about that this is the combination end to end. So end to end connections are known as series combination, right?
Yes.
So now let's try to connect all them into a series and let's make a circuit. So let's suppose if there is a circuit and we are going to connect three resistors over here, and there are three resistors, one, two, and three, right? So there are three resistors in series and there will be a potential difference or a voltage supply over here through which current is going to pass through all these resistors, right? This is R1, this is R2, this is R3, right?
Yes.
So we know that current will always flow from the positive side until and unless they are asking about the electron flow, right?
Yes.
Okay. So now when current starts flowing into the circuit before finding the resistance, if you remember the Ohm's law, so what is the equation of Ohm's law? That is equals to V is equals to IR. That is the
Ye-
Ohm's law, right? And we are calculating the resistance. So if we skip the value of resistance or if we not talk about the value of resistance, so what are the other two factors? Voltage and electric current.
Yes.
So these are two quantities. Now first discuss that which quantity will be variable in this circuit and which quantity will be constant in this circuit. So what do you think, that voltage will remain same in this circuit or the electric current?
Electric current.
Electric current, the reason behind this because electrons will flow from one path into the circuit, right? Because
Yes.
there is only one path for charges or that are going to flow from the circuit, so there is only one path for them. So that's why we can say that the current or the value of electric current will remain constant throughout the circuit.
Voltage will change due to the
Voltage will be
resistance, yeah?
variable, yes, because each resistor has its own resistance. Maybe they are same, but we know that when the first resistor resists the current, so the intensity of that current or the potential of that current or the potential of those charges will decrease, right? Just
Yes.
like the speed breaker, when three speed breakers are in a straight line, so our speed will continuously braking after every interval. So that will affect the flow, right? But charges
Yes.
will still flowing in a straight line through one path. So that's why current is constant, because direction is constant, right? So by taking the reference of this concept, this is very important rule, because this will also help you to solve many questions, because sometimes they give series combination and they ask to calculate the electric current through each resistor. So we know that the current through one resistor will be same for the second and the third. So we don't need to calculate for each resistor. We just calculate the value for one and we can say that they are connected in series. So that's why the current will be same for other two resistors or the resistors that are connected in the circuit, right?
Yes.
So this rule is also mentioned in your book, and that is very important to remember, because that will help you to solve the MCQs and some questions, numerical questions, in a short interval of time without wasting any extra time or without getting wrong concept, right? So let's
Yes.
suppose if we are going to find the resistance, so let's try to find the final resistance. So we know that the current is constant, only the value of voltage is variable over here. So if we take the total voltage as the sum of individual voltage like this, V1, V2, V3, these are the voltage of individual resistance, right?
Yes.
So according to Ohm's law, V is equals to IR. So we write same concept, V is equals to IR, V is equals to, because I is constant, so we are not writing I1, I2, or I3, right?
Yes.
So we only write IR1, IR2, IR3, right? This is the combination. And current is constant, so we can take common and cancel out on the other side. So the final expression will be like this, that R will be equal to R1 plus R2 plus R3. So this is the final result of series combination, and this will give you the idea that in series combination the final resistance will be greater than the individual resistance, right? If there are three resistors over there, now if we combine
Yeah,
these resistors, let's suppose our given values is equals to 3 plus 2 plus 4. Okay,
yes.
so our answer will be equal to 9 ohms, right?
Yes.
And we correct this value of 10 into 9, right? Because we are getting 9 resistance, right?
Yes.
So the total resistance is equals to 9 ohms, and now we come to know that we need to connect them in series combination just like the circuit, right?
They
And
are in series combination, yeah.
yes, so if they want to conclude this concept into words rather than the equation, so there is very important factor over here, and that important factor is the effective or this final resistance is also known as effective or equivalent resistance. So they ask you in questions that calculate the effective resistance or equivalent resistance, right? I am also going to write this term into the statement, so that will help you to remember the concept. If they ask you in any question, so you know that we are going to calculate the total resistance, right?
Yes.
So statement will be like this, that in series combination, the effective or the equivalent resistance,
Equation different in the non-series combination.
yes, it will be different in parallel combination, but same formula will apply in series combination. Whatever the value of resistors are given, you just need to add them to find out the final value. So effective or equivalent resistance will be equal to sorry, we can say will be equal to the sum of individual resistance, and there is also a very important factor that our effective or final resistance will be greater than the individual one, right?
Yes.
So we can also write it as sum of individual resistance, or we can say that the effective resistance, or we can simply say Re in short, will be greater than
Even the effective and the equivalent
yes.
resistance will the question will specify if it is non-combination, non-series
We can also
combination.
write, yes, we can also write capital R for that, for this. And you don't need to mention for series and parallel combination separately, because when they are giving you a question, so it is already understood that what they are asking you to solve in the question, right? So there will be no confusion in Re or capital R, because we
Uh,
are already mentioning R1, R2, R3 over there, that are the individual values of the given resistors, right? So
yeah.
Re will be greater than the individual resistance. You can see that in the question, the greatest value is of 4 ohms. Now we are getting value of 9 ohm, that is greatest among all the given resistors, right?
Yes.
So this is the concept of series combination, right?
Yes.
Okay. So this is the first concept. Any confusion?
No.
Okay. Now if we talk about parallel combination, so if we are talking about a parallel combination, so in parallel combination, again, we need three resistors, right? We are talking about same three resistors. So three resistors are going to be like this. They are connected with each other like this. This is a single point. This is the other point. So these are connected at a same end, right?
Yes.
This is left, right, or this is left. And now they are connected with a potential difference, or we can say there is a battery over there. Okay,
Yes.
and this will be R1, R2, R3, right?
Yes.
So now we can see that when current starts flowing from the positive end, right, and
Yes.
it reaches this terminal or this junction, so current will divide into three parts at the same time, right?
Yes.
So the value of electric current will be variable now, right?
Yes. It will, like it will
So
split.
yes, it will split according to the capacity of resistance. Where resistance is high, electric current will be low, and where resistance is low, electric current will be high. So in that case, we easily say that the value of electric current will be variable in parallel combination, right?
Yes.
So now current will become variable and voltage will become constant because we have two joint or two junctions over there, and we can easily measure the voltage of the whole circuit through two terminals, right? So
So
that
like the voltage is all over the same?
yes, voltage will remain same because voltage will start flowing from this end. Then we can find out the difference over this end, right?
Yes.
Let's suppose if there is a 9-volt battery over here and there is a 9 volt, because at this point no energy is consumed, and after passing from that point, let's suppose our final voltage will be equal to 3 volt, so we will get the difference of 4 volt, right? So 4 volt energy is going to be consumed by these resistors or the circuit, right? So
Yes.
that will give you a single value of voltage. So voltage is equals to 4 volt in this condition. So in that case, we can say that voltage will remain constant for each resistor or throughout the circuit, right?
Yes.
So now again we going to calculate the resistance, and to calculate the resistor we again going to take help from the Ohm's law, and Ohm's law is equals to V is equals to IR, and in parallel combination we are going to make I as a subject, right? So we are
Yes.
taking I as a subject, and when we make this subject, so now we know that we need to find out the total electric current through the circuit. So total current from the circuit will be equal to I is equals to I1 plus I2 plus I3. So that will give you the final value, and I is equals to V over R, V over R1, V over R2, V over R3, right? Again taking voltage common over there, so we will get the final equation like this: 1 over R1 plus 1 over R2 plus 1 over R3. Derivation is not important for you. This is just for the concept. So you will get the clear concept that why actually they are in reciprocal and why they are in algebraic sum, right? So the
Yes.
concept is important, derivation is not important because they don't ask you to drive the final equation. So equation is just for the concept, because you need to know about that where current and where voltage will be constant or variable, right? Because this is very important to know.
Yes.
So now we got final conclusion over here, and if we write the final statement for it, so final statement will be like this: that the effective or equivalent resistance in parallel combination will be equal to the reciprocal of individual resistance, right?
Yes.
And another interesting thing, that if we are using the same values of the previous resistors, right? So the what is the value of the smallest resistor? 2 ohms, right?
Yes.
2 ohm is the smallest value. So when we combine these resistor into parallel combination, so we will get the final resistance or equivalent resistance less than 2 ohms, right? So the equivalent resistance will be less than the individual one, right?
Yes.
So this is another important thing that you need to know, that the final resistance or equivalent resistance will be less than the individual value of resistor. If there are 10 resistors over there, so final value will be less than the smallest resistor among all those 10 resistors, right?
The final value will be lowest.
Yes, you can also check by calculation the same values. Let's suppose if we are going to calculate the values, so we need to use the previous value of the question, that is equals to 1 over 4 plus 1 over 3 plus 1 over 2. So by calculating these values, you will get the answer, and you will
9.
get the answer, and that answer will be less than the individual one, right?
Oh, the answer will be 9. Yeah. Wait, no.
First, you will get the answer in the form of 1 over r, right? Then you will get
Yes.
the answer of r by reciprocating that value which you calculated over here. So what is the value of final resistance?
The wait. It's 13 over 12.
It will be equal to 12 over 3 over 12.
No, 13 over 12.
13 over 12. Okay. By reversing their order, we will get the value of r like this, 12 over 13, right? So that 1 over r becomes r, and that 13 over 12 becomes 12 over 13, right?
Why 12 over 13?
Because
How?
on left hand side, you can see that there is a value of 1 over r, and we need to calculate the value of r only, right? Because r is
Yes.
the symbol of resistance. So that's why we need to calculate the value of r rather than 1 over r, right?
Yes.
So this is the reason behind that.
So
So
it should be negative 12 divided by 13.
yes, previously it was 13 over 12, now it will be equal to 12 over 13, right?
Yeah, negative 12, I guess.
No, no, not negative 12. Order will be changed. The numerator will become denominator, and denominator will shift it into the numerator, right?
Yes.
So this is the concept. So what will be the answer now? In simple notation,
It's 0.92.
yes, 0.92. So when you are going to make a small resistance, right? If there are greater values of resistor over there, and you need to make a resistor of very low resistance, right? In decimals also. So you need to connect them into parallel combination. And when you are going to make a great or high value resistor, so in that case, you need to connect them, those resistors, into series combination, right?
Yes. Answer, you said that the resistance will be less than the
The
individual
individual,
resistance.
yes.
Yeah.
So the
But how
smallest
it is?
resistance, you can see in the question that the smallest resistance is of 2 ohms, and we are
Yeah,
getting
but
answer
it's not equivalent to 13 over 12.
13 over 12. Actually, there is a reciprocal value, right? Because resistors in denominator, we want resistor in a single form like numerator over here. So that's why we reverse the order, or you can cross multiply them, right? This concept can
Yes.
also be made with the help of cross multiplication,
Yes.
right? It will be equal to 12 over 13 on left hand side, and r will be shifted on right hand side. Okay,
Okay.
so this is the concept, right? Any
Yes.
confusion?
But I still don't get that how this value is less than the individual.
Individual means, let's suppose we have three resistors, right? 4, 3, and
Yes.
2 ohms, right? So
Yes.
smallest value of resistor in our case is equal to 2 ohms. This is the smallest resistor
Yes.
in our case. And we are getting the final answer, which is less than this smallest resistor, right? So that is the meaning of individual resistance, that you can compare that value of final resistance with the individual value of resistance that are given, right?
Okay.
So
So
then
you
you
only
will,
compare with the
right,
denominator.
smallest value, not denominator, only the values of resistor that are given over here in the question. We are comparing these values, right? All three values. So when we are joining them in series, so we compare with the greatest value, that is of 4 ohms. If we compare this value with the 4 ohms, so 9 ohms is greater than 4 ohms, right? Because 4 ohm is the biggest resistor in our circuit, and we are getting value which is also very greater than 4 ohms, right? And when we are talking about the smallest value, so we compare with the smallest resistor, right?
Yes.
So that is the concept, right?
Yes.